Hello there Year 6ers, it's Mr. Conway here. Now for today's how-to guide we're going to be looking at to solve equations through word problems. And I have a word problem here and I'm going to model how to solve this kind of question. So it says, here is a word problem completed with drawings and algebra. So the word problem is here in this part of the table. I think of a number, I add 3 and my answer is 5. And we've got the concrete and the algebraic expressions to go with it. So first of all what I'm going to do is actually build this word problem. So it says here, I think of a number. Right, so I'm going to use this hundredsteins as my a number. Even though it's 100steins, it's not worth 100. It could be anything, okay? So this is my I think of a number. To this, I'm now going to add 3, it says. So I'm going to add 3. 1, 2, 3. And it says my answer is 5. So I'll then do an equal sign and then add 5 to here. 1, don't run away, 2, 3, 4, 5. So I've now built my word problem, okay? But the question says this, what does the cube represent? And the cube is in this example is here, and that's what I've used as my hundreds counter, okay? So what does this actually equal? What is my starting number? So just before I move into that, I'm going to just change this a little bit, because I've got the concrete, I want to use the algebra, okay? So what do I already know? Well, I know this is 5. So I'm going to remove those 5 counters and replace it with the number 5. I know this is plus 3, so I'm going to remove the 3 counters and I'm going to put the number 3. But I do not know this. So for now, I'm going to put a question mark, because that's what I need to calculate. That's what I need to figure out. This is my cube. But in algebra, remember, we use letters instead of numbers and symbols. And if you notice that we're using the letter X, and as we said before, for the letter X, we don't just use a normal X because we get confused with the multiplication sign. We use this fancy X, which is a bit like 2 backwards C's. So I'm going to cross that out. Actually, I'll squiggle it out so we don't get confused with the letter X. So X is what I need to calculate. What is X equal? What's that starting number? X plus 3 equals 5. Well, to solve out this missing number, all I need to do is do the inverse. And some of you might have spotted that already. So if I was to make the inverse of this, I would start with my total, which is 5. Instead of add 3, I will use the inverse and subtract it. And that will give me x, whatever x is. So we can solve that now. 5 subtract 3 is simply 2. So my starting number was 2. And I can put that in there. And I can check that, because if I substitute, remember we did substitution in a previous video, if x equals 2, then this is going to be 2, this is going to be 2, 2 plus 3 is 5. Hello, we did it, correct. So that's just one example. I'm now going to just model a different word problem. We're still going to be using the same type of method, okay? And your question says this, I think of a number, we've got to be like Sherlock Holmes here. I think of a number, I add 14, and my answer is 20. Right, well, first of all, however you do this at home, you can do it pictorially or using manipulatives. I'm going to start building this first. So I think of a number, it's this. This is my number. I don't know what it is, but it's going to be this for now. Now, to this mysterious number, I need to add, actually I'm going to use a bit of a thicker pen here. To this number, whatever it may be, I am going to add 14. So there's my 10, counting on, 11, 12, 13, 14, and my answer is 20. So I'm going to do an equal sign, and I now need to make 20. Okay, so I've built my algebraic formula, and now I need to deconstruct this slightly so I can make it using letters and numbers. So what do I already know? Well, I know it equals 20. So I'm going to remove that and put a 20 here. I need to add 14. Right, I'm going to remove the 14 and replace it with the number 14. I don't know this value. I don't know this number. But because I'm using algebra, I'm going to replace this with a letter. And this time we're going to use the letter N. Remember, N is a popular one for us to use because N means any number. So I've now got my algebraic formula. N plus 14 equals 20. But what on earth is N? Some of you right here are screaming at your computer screens, just do the inverse, Mr. Conway. Well, that's exactly right. So I'm going to do the inverse now. 20 was my total. Instead of add 14, I'm going to subtract 14. And if I do 20 subtract 14, I'm going to end up with 6. And that's what n equals. N equals 6. So if I now substitute it, just to check that my calculations are correct, I've got n, wrong blue, n here, I'm going to say that this is equals 6, because that's what I've just calculated. Here it is. So 6 plus 14 equals 20. Now then, if that was a little bit confusing about using the inverse, another method that you could use is using a bar model, okay? So if I had a look at my original expression, if I just cross this out for now, of n plus 14 equals 20, I could always draw a bar. I know what my total is. My total is 20. I know one part of it is 14. So n is this part here. So then all you'd have to do is 20 subtract 14 would give you n. And as we've already calculated, it is 6. So there we are, year 6s. That's to solve equations through word problems. And I really do recommend either building the formula first, replacing what you've built with numbers, and then using the inverse to solve what your starting number was. So there we are, year 6s. That was today's algebra. I hope you have a really good day today and enjoy yourselves. Goodbye.